Hi everyone. In today's lesson, we're going to talk about verifying trig equations. We're going to use the identities that we spoke about for the past couple of days to do this. But before we can do that, I want to talk about how we can factor with trigonometric expressions. So here in this first problem, we have cosine of theta minus cosine of theta sine squared. That's actually a typo. Let's just make it sine of theta. So what I'm going to do is I'm going to show you how this is exactly the same thing as factoring x minus xy. So in this scenario over here, and I say factor using GCF, you would say I could divide both pieces by x. And the way that we do GCF is we write the GCF on the outside, followed by an open parenthesis, and then we divide. So x divided by x is 1, and xy divided by x here, these x's will cancel, leaving us with y. So this is the exact same thing as this. I just said x was cos and y was sine. So as you can see here, the GCF is actually cos. So we're going to divide both pieces by cosine of theta. And since that's my GCF, we pull it on the outside, followed by an open parenthesis. And then we do our division. Anything divided by itself, cos divided by cos is 1. And cosine divided by cos, these coses will cancel, leaving you with sine. So 1 minus sine of theta. So factoring with trigonometry is definitely a possibility, first using GCF. Let's talk about a dots example. All right, let's do a dots example. So just for simplicity, I'm actually going to change these to 2's. It'll make our lives a little bit easier. So dots, recall, is when we have a difference of two perfect squares. So the one that you're used to seeing would be something like this, x squared minus 25. Everyone knows that that's x plus 5, x minus 5. Sometimes when there's no number, it could just be variables. So I could have x squared minus y squared. You still break it up the same way that the front end of the parentheses get x times x to give me the x squared, and the back end of the parentheses get y times y to give me y squared, and then a plus and then a minus. So we're going to treat this one the exact same way. So you can consider sine squared as your x squared, and you can consider cosine squared as your y squared, and simply do x plus y, x minus y. So in this one, we're going to do sine of theta in the front, another sine of theta in the front, y. That gives me sine times sine gives me sine squared. And then at the back end, to get cosine squared, we're going to do cos times cos. So then this will be cos theta, and then this will be cos theta. And then your plus and your minus. So that's an example of how we can do dots with trigonometric expressions. The next type of factoring will be with trinomials. You could either use AM if the leading coefficient is 1, or you can use AC or guess and test if the leading coefficient is bigger than 1. So in this situation, you should be able to see that this is a trinomial here with 3 terms where the leading coefficient 2 is bigger than 1. So what I'm going to do is I'm going to let x equal sine of theta. And every time I see a sine of theta, I'm going to put it in with an x instead. So 2 sine squared theta will correspond to 2x squared, and then minus x minus sine of theta, and then minus 3. So I'm just going to do a review of the AC method. If you are a guess and test person, then feel free to do that as the video plays out and see if you get the same answer. The AC method works like this. We're going to multiply the first and the last, and that gives me negative 6x squared. And we're looking for the factors that are going to add to a negative 1x. So negative 6x squared here are the factors. So I'm thinking it's either negative 3x and positive 2x, or a positive 3x and a negative 2x. So let's just see which pair is going to add to that negative 1. Negative 3 plus 2, yep, that's negative 1, that's actually it. So this is going to be the pair that goes in the middle. So we're going to bring down my first term, my 2x squared. We're going to rewrite our negative 1x as our negative 3x plus 2x. And then we're going to bring down our last term of negative 3. And then we do our factor by grouping. Group the first 2 terms, group the second 2 terms, bring down the sign in the middle. And the GCF of the first 2 terms is x, and you're left with 2x minus 3. The GCF for the second two terms is actually only 1 because there's no other factor, and then you'll be left with your 2x minus 3. Now remember, with grouping, this 2x minus 3 is technically another GCF, so you pull out the GCF, followed by the open parenthesis, and you're left with this x plus 1. So technically, these are our factors of this expression. Now, since I let x equal sine of theta, what I can do now is, in my answer for my factors, I can put my sine of x back in. So everywhere I see an x, I'm going to put sine of theta. So 2, and then now we're going to do sine of theta. Then we'll bring down our minus 3. And then over here, our x was really sine of theta, and then plus 1. So this is honestly the way that I would prefer you to factor, is by using a let statement. If something like this is a little bit harder to do within the trigonometry, so there's nothing wrong with changing it to x, factoring it, and then putting it back. So our final answer here is simply 2 sine of theta minus 3, and then sine of theta plus 1. All right, so those are the three main factoring techniques that we're going to be using when we verify expressions. So if you take a look at the back, the goal here is to verify a trig equation. The directions specifically just say that. Verify each trig equation below. So what a trig equation is an equation that has an equal sign, and you need to verify that the left side of the equation equals the right side of the equation. And with verifying, you're only allowed to simplify one side of the equal sign to get it to look like the other. You cannot move across the equal sign, and you usually start with the more complicated side. So if I were trying to verify these equations, what I would do is draw a little line or squiggly line down here, wherever the equal sign is. And your goal is to get the left side to equal the right side, but you're only allowed to touch one side. Usually I would start with the more complicated side. So maybe this side is more complicated, this side is more complicated, right? And the goal is to get it to equal the other two. So what I'm actually going to do is I'm going to ask you guys to try these at home and try to use the techniques that we used in the previous page to help us. This one you might be able to do just by rewriting it using sine or cosine. This one you might need to factor. So try them. I suggest trying them with a pencil, so that way when you come into class tomorrow, we'll start here by going over these and see if you did it correctly or not. All right, that's it for today. If you guys have any questions, now's a good time to jot them down. Otherwise, I will see you in class tomorrow. Have a good night.